Let me start by introducing us with geology staff, and just to say that the BSc Geoscience degree is for the most part delivered by geology staff. We've got Professor Andy Wheeler, who's the Professor of Geology here in UCC. Andy is a marine geologist and does a lot of offshore work. Pat Meere, that's me. I'm the head of geology. I study mountain belts and I study structural geology. Professor Maria McNamara, to my right, is a paleontologist and does some really, really cool stuff looking at how fossils are preserved and what that tells us about evolution and the history of life on this planet. Bottom left-hand side, Dr. John Reevy. John is all about igneous rocks, volcanoes, volcanics, and that whole side of things. Kate Kasiva is a relatively new staff member, and Kate, she works in geochemistry and the geochemistry of the deep earth, which is impressive stuff. John Wetherill is also a relatively new staff member. John is an applied geoscientist. He's a hydrogeologist for the most part and studies water resources and the environment. And finally, Ed Jarvis. Ed is a paleontologist and sedimentology, studies ancient environments, and he happens to be the first year coordinator for geoscience here as well. So I suppose my first question to you is that are you interested in science and the environment, but you're not quite sure which subject or which area to study at university? And hopefully this little talk will give you some insights into the geosciences and what that might mean for you. Entry stream is CK404, Biological, Earth and Environmental Sciences. As you know, you enter the university under that stream title. You've got a common first year, so everybody does the same first year who enters CK404, and we'll look at that now in a second. And then after first year, and this is a really, really good thing, I think, you have a choice of 5 degree outlets after that first year. The choice of degree outlets, here they are: BSc Geoscience, which is what I'm primarily talking about in this presentation, but we also have the BSc Environmental Science, BSc Zoology, BSc Ecology and Environmental Biology, and BSc Applied Plant Biology. They're your degree options from CK404 after your year one. So, you know, here is a list to give you a flavor of that common first year. You have each module, these are subject modules. You've got 10 credits, 2 modules of geoscience in first year. And by the way, we assume little or no previous knowledge, so you don't have to have done geography or anything like that to do geosciences here in UCC. We start from scratch. So we've got 2 modules of geoscience. We've got a module of physical geography. We've got 2 modules of environmental science, 3 modules of biology, a module of maths, introductory maths, a module of chemistry, basic chemistry. That's 10 credits, so that's quite a big module, but it's important that you get a foundation in chemistry, and physics, 1 module of physics, and that's a total of 60 credits. Okay, so that's what your first year will look like, and everybody coming into CK404 will take these modules. So what is geoscience? And I suppose the first thing to say is that the degree that we have here in UCC is delivered mostly by geology staff, but also some geography staff will deliver the program. And it's, I suppose, in its broadest sense, and it's a big, big topic, as you can imagine, it's the study of the Earth in the first instance, and that's our main interest, but also the other planets. So we look at its formation. How did this planet form? Its structure, from the core to the outer crust, its composition, the chemistry of it, its history. Earth has had this planet has a long history, over 4 billion years of history. Geologists study time and that aspect of time when we study the planet. And resources, it's quite an applied science. So in other words, we're talking about decarbonizing society in the coming years and decades. To do that, we will need resources for things like wind farms and for batteries, etc. Geoscientists are central to that resource exploration and delivery. I mentioned time, and again, we geologists this makes us quite unique, I suppose, in terms of the sciences, in that we look into deep time, going back, as I say, over 4.5 billion years to the formation of the planet, and it gives us a unique perspective on what's happened in the past. Things like the origin and evolution of all plants and animals. Geologists, paleontologists are very much central to that. It gives us a unique insight into past catastrophes, things like volcanic eruptions, major climate fluctuations. And I suppose the key here is that reading that history of the planet gives us unique insights into what might be happening in the future. Another reason to study geoscience is space, and what I mean by space here, that it's the dimension of space. In other words, you get to look at things in different scales. On the left-hand side here, we have this is a hot springs from Yellowstone National Park in the United States. The top right there is 50-meter scale. You can see a road on the top left-hand side of that image. That's quite a large image. That's taken from this was taken from a drone. On the right-hand side, we've got a microscopic section of a rock. So that's only that whole field of view that we see on the right-hand side, those lovely colors and those minerals, that's just about 1 millimeter across. We can tell an awful lot about the history of the rock when we look at these rocks in thin sections like that. So we work from all scales, from the planetary scale down to the microscopic. Observation is really important. So if you like, if you're a visual person, then I think that geoscience might suit you. Observations are the absolute backbone of what we do, particularly looking at structures in the field. You know, we look at landscapes which are quite static to active volcanoes which are incredibly dynamic. But one of the core ways of acquiring data from these various these features is observation. Things like satellites then have opened up, we can look at observe the planet from space, and that gives us a unique perspective on the planet and how the planet works, and from that point of view, we get a real important understanding of how the planet works. Climate change is a big issue, and I don't have to tell you about that. And I think the geosciences are absolutely central to understanding climate change, because I mentioned this already, we've got this long history that we can look at, and we can see how the planet has behaved in the past by studying rocks and studying geological features. And that will help us understand what the impact of climate change will be to our planet, both in the short and long term. So it gives us a really, really important, if you like, primer to what to expect in the future years. Fieldwork is so important, and this is what I think, if you like the outdoors, then I think you should again consider geoscience, because it's by far the most effective way of learning about our planet. You can read lectures, you can read books, you can go to lectures, you can go to laboratories and practical classes, etc. But the bottom line is you need to get into the field and see the landscapes, see the rocks, see the features close up. We run field courses in Ireland, in places like Antrim, Kerry, and Wexford and Clare, and also the Scottish Highlands and in Greece. And these are just a couple of images that we have from those field courses. First year field course, we go to Antrim. Second year field course, this is a group of second year students working in the Dingle Peninsula in Kerry. The third year students head off to the west coast of Scotland and to the Isle of Mull, and do some fantastic work there. And you can see they're all wrapped up. This was run in March, April. But you can clearly see, even though they're wrapped up, they're enjoying themselves, lots of smiles on their faces. And our final year, our fourth year field course is run in Greece. And basically, this is an area that's seismically very active, and there's active tectonics, and there's lots of cool stuff to see and do on that particular field course. So, in practical terms, a geoscience degree will make you highly employable because you get a good scientific training. It is a STEM subject, end of story. That is a really, really good STEM subject to study. You end up with a whole range of transferable skills like fieldwork skills, independent thinking. When you're doing fieldwork, you have to think for yourself and critical analysis. That's a really important aspect of it. You will do quite a bit of laboratory work as well. So there's a nice mix of fieldwork and laboratory work. Increasingly, you'll need to be IT literate. So there's lots of software packages that you'll need to learn to use, data analysis. Then basic skills like scientific writing, which is so important and what employers are looking for in this day and age. You'll learn quite a bit of that. And things like GIS, Geographical Information Systems, and working in a GIS environment. You'll also get an opportunity in your year 3 to work with a local company and as part of a work placement scheme. And your knowledge and variety of skills, I think, will make you, you could move into a whole plethora of different career paths. And this diagram shows, and it's a very complicated diagram, a very busy diagram, so apologies for that. But geology and geoscience pathways are shown here. Things like geophysics, studying natural hazards, remote sensing, which is the satellite work, hydrogeology, the thing about the area that John Wetherill works in, looking at studying water as a resource. Environmental geology is increasingly becoming important. We've got a new master's in applied environmental geoscience here in UCC. Geochemistry, stratigraphy, paleontology comes into it. That's here, and then things like studying volcanoes and igneous petrology are there. So you've got a huge potential range of career options. There's a global shortage of geology and geoscience graduates. If you go to the Earthworks webpage, it'll give you a kind of a feel for the different opportunities that are out there. Our graduates are so highly sought after locally and internationally. So that's certainly the case. The main careers are in hydrogeology, environmental geology, engineering geology, and resource geology. These are the kind of the main topics that people get employment in. Graduates may also choose to continue to do a master's, and I mentioned that we have a thought master's here in UCC that in terms of applied environmental geoscience. The Irish government have invested quite a bit recently in geoscience research, so there's plenty of research opportunities there as well. Geoscience and geology in the 21st century is so important. If we're talking about the substantial supplies of critical metals will be required for things like IT computing chips, for green technologies, electric car batteries, solar panels, wind farm turbines, they all need resources, and geoscience will need to help provide those resources. Hydrogeology, the search for clean and reliable water supplies, is becoming maybe not such a big an issue here, but certainly globally it's becoming a huge issue, and the world will need good hydrogeologists, hydrogeoscientists. Environmental geology looks at things like contaminated land, restoring industrial sites, waste management disposal. That is a growing area and an important area. Engineering geology is more, I suppose, looks at things like building roads, tunnels, slope stability, wind farm sites. And a lot of these two topics we cover in the one-year MSc that we have after our primary BSc Geoscience here in Cork. I'm going to finish by just giving you a few quick profiles. This is Emily Archer. She graduated with a geoscience degree in 2017, and then she did the applied environmental geoscience masters in 2018. She's currently a graduate geotechnical engineer with Feely Timoney here in Cork in the city. She's done a very, very good YouTube carpool karaoke type video on geoscience. Check it out if you can. It's well worth a view. And at the other end of the spectrum, we have Michal Lehan, who again is a geoscience graduate in 1988. He's my vintage. He did his PhD in 1993, again in UCC. He worked in fossils, and he went on then, because he got such a broad training in his geoscience career to that point. He joined the EPA in 1995, worked in environmental assessment and reporting, went on to serve as the program manager for the Office of Radiological Protection, which is an important role. And recently was he appointed in 2016, he was appointed as a director of the Environmental Protection Agency. So quite a success story with a geoscience background. So I'm going to finish there. I'm going to just put up two images here of myself, the head of geology. If you've got any questions, just email me. Please do email me, p.meere@ucc.ie, or you might want to chat to Ed Jarvis, who's the first year coordinator, d.jarvis@ucc.ie. We'd be very, very happy to chat to you.